Welcome. Today's topic, Domain Name System (DNS). What is DNS? The Domain Name System (DNS) is the phone book of the Internet. Humans access information online through domain names like abc.com, xyz.com, etc. Web browsers interact through Internet Protocol or IP addresses. DNS translate domain names to IP addresses so browsers can load Internet resources. Each device connected to the Internet has a unique IP address which other machines use to find the device. DNS servers eliminate the need for humans to memorize IP addresses such as 192.168.1.1 in IPv4 or more complex newer alphanumeric IP addresses as you can see in the image. How does DNS work? The process of DNS resolution involves converting a host name such as www.example.com into a computer-friendly IP address such as 192.168.1.1. An IP address is given to each device on the Internet, and that address is necessary to find the appropriate Internet device, like a street address is used to find a particular home. When a user wants to load a web page, a translation must occur between what a user types into their web browser, example.com, and the machine-friendly address necessary to locate the example.com web page. In order to understand the process behind the DNS resolution, it's important to learn about the different hardware components a DNS query must pass between. For the web browser, the DNS lookup occurs behind the scenes and requires no interaction from the user's computer apart from the initial request. There are 4 DNS servers involved in loading a web page. Number 1 DNS recursor, number 2 root name server, number 3 TLD name server, and number 4 authoritative name server. DNS recursor. The recursor can be thought of as a librarian who is asked to go find a particular book somewhere in a library. The DNS recursor is a server designed to receive queries from client machines through applications such as web browsers. Typically, the recursor is then responsible for making additional requests in order to satisfy the client's DNS query. Root name server. The root server is the first step in translating or resolving human-readable host names into IP addresses. It can be thought of like an index in a library that points to different racks of books. Typically, it serves as a reference to other more specific locations. TLD name server. The top-level domain server, TLD, can be thought of as a specific rack of books in a library. This name server is the next step in the search for an specific IP address, and it hosts the last portion of a host name. In example.com, the TLD server is com. Authoritative name server. The final name server can be thought of as a dictionary on a rack of books in which a specific name can be translated into its definition. The authoritative name server is the last stop in the name server query. If the authoritative name server has access to the requested record, it will return the IP address for the requested host name back to the DNS recursor, the librarian that made the initial request. There are typically 8 steps in a DNS lookup. Number 1. A user types example.com into a web browser and the query travels into the Internet and is received by a DNS recursive resolver. Number 2. The resolver then queries a DNS root name server, dot. Number 3. The root server then responds to the resolver with the address of a top-level domain, TLD DNS server such as .com or .net, which stores the information for its domains. When searching for example.com, our request is pointed towards the .com TLD. Number 4. The resolver then makes a request to the .com TLD. Number 5. The TLD server then responds with the IP address of the domain's name server example.com. Number 6. Lastly, the recursive resolver sends a query to the domain's name server. Number 7. The IP address for example.com is then returned to the resolver from the name server. Number 8. The DNS resolver then responds to the web browser with the IP address of the domain requested initially. Once the 8 steps of the DNS lookup have returned the IP address for example.com, the browser is able to make the request for the web page. The browser then makes a HTTP or HTTPS request to the IP address. The server at that IP returns the web page to be rendered in the browser. The image describes the complete DNS lookup and web page query steps as said before. What is a DNS resolver? The DNS resolver is the first stop in the DNS lookup and it is responsible for dealing with the client that made the initial request. The resolver starts the sequence of queries that ultimately leads to a URL being translated into the necessary IP address. It's important to differentiate between a recursive DNS query and a recursive DNS resolver. A typical uncached DNS lookup will involve both recursive and iterative queries. The query refers to the request made to the DNS resolver requiring the resolution of the query. A DNS recursive resolver is a computer that accepts a recursive query and processes the response by making the necessary request. What are the types of DNS queries? In a typical DNS lookup, 3 types of queries occur. Number 1, recursive query. Number 2, iterative query. And number 3, non-recursive query. By using a combination of these queries, an optimized process for DNS resolution can result in a reduction of distance traveled. In an ideal situation, cached record data will be available, allowing a DNS name server to return a non-recursive query. What is DNS caching? Where does DNS caching occurs? The purpose of caching is to temporarily store data in a location that results in improvements in performance and reliability for data request. DNS caching involves storing data closer to the requesting client so that the DNS query can be resolved earlier and additional queries further down the DNS lookup chain can be avoided, thereby improving load times and reducing bandwidth or CPU consumption. DNS data can be cached in a variety of locations, each of which will store DNS records for a set amount of time determined by a time to leave (TTL). Browser DNS caching. Modern web browsers are designated by default to cache DNS records for a set amount of time. The purpose here is obvious. The closer the DNS caching occurs to the web browser, the fewer processing steps must be taken in order to check the cache and make the correct request to an IP address. When a request is made for a DNS record, the browser cache is the first location checked for the requested record. In Chrome, you can see the status of your DNS cache by going to this link. DNS caching also occurs in operating system, which is known as OS level DNS caching. So that's all for today. I hope you like it. Thank you.